Alright, so the next method that we're going to study is how metal oxide can react with acids to form salt and water. So the salt that we want to prepare in this example is copper sulfate. Now this is a little different than the method that we have studied earlier. Copper cannot be directly added to sulfuric acid to form copper sulfate and water. Why? Because copper is below hydrogen in the reactivity series. Copper is an unreactive metal. It will not react with dilute sulfuric acid to give us salt and water. So that is why we cannot use copper, but we need copper oxide. We need an oxide of copper to react with sulfuric acid if we want to get copper sulfate. Alright, so we'll start with copper oxide and we'll add copper oxide and sulfuric acid, which is obviously aqueous, copper oxide as solid, and this will give us copper ions from copper oxide and sulfate ions from sulfuric acid, and we can get copper sulfate and water. Alright, so how it is done? It is done in exactly the same way that we have used earlier. In the previous case, we added metal into an acid, and in this case, we cannot add metal because it is unreactive in this case. So we'll add copper oxide and sulfuric acid to get copper sulfate solution and water. And again, we'll add excess copper oxide so that it reacts with all of the sulfuric acid that is present, and so that the solution that is formed, it is purely copper sulfate and there is no sulfuric acid left behind. Alright, so the step 1 says add some copper oxide to dilute sulfuric acid. It will dissolve this when the solution is warmed. Alright, add more until no more dissolves, which means add in excess. This shows that all the acid has been used up. When no more copper oxide is being dissolved, it means that all the acid has been used up. And the second step is, because copper oxide was in excess, so we'll remove that excess copper oxide by filtering the solution, and we'll obtain the solution of copper sulfate. And now, okay, let me just read this out. Remove excess copper to oxide by filtering. This leaves a blue solution of copper sulfate in water, copper 2 sulfate in water. So now we know that we only have copper sulfate dissolved in water, and we want to remove water from it. So we'll simply heat the solution. We'll heat the solution to evaporate water, and what will be left behind is copper sulfate. So let me show you diagrammatically as well. It is the same diagram that we saw in our previous method. It will make more sense now. Just wait a minute, let it load. Yeah. So we have over here copper oxide that is being added to sulfuric acid, and we are warming this solution over here so that copper oxide is dissolved. And when no more copper oxide dissolves, we know that all the acid has been used up, and we'll remove the excess copper oxide, which is unreacted, and we'll obtain a solution of copper sulfate. So this copper sulfate solution, it will be heated to evaporate water. Water will be evaporated and will be left with a solution of copper sulfate. So we'll leave it for cooling, and crystals will start to form. And these crystals formed will be formed in water, and excess water will be removed. These crystals will be filtered out and they will be dried, and will have pure crystals of copper sulfate, hydrated copper sulfate. Hydrated means it has water content in it, which is necessary for crystallization, and we call this water as water of crystallization. The crystals that form, they have certain properties. They are regular geometry shapes such as cubic or hexagonal. They're not amorphous. Amorphous is powder. powdered particles have no shape, like you see in talcum. Alright, the crystals of salts, they're different than amorphous powder. They have certain geometry, they have certain shapes. They have flat faces, straight edges, and sharp angles, and same angles between adjacent faces. Alright, they have a certain geometry. So that is all about formation of salts by metal oxides. And next we'll see, and same is the method with metal carbonates as well. It is the exact same method. The only difference is in the equation, that with metal carbonates we get, instead of salt and water, we get salt plus carbon dioxide plus water. The method of preparation is same as this one. Excess metal carbonate is added into an acid, and then the unreacted carbonate is filtered out. Then the solution is formed. It is dried to get crystals. Crystals are then filtered. uh, they're left to cool for the crystal formation, and excess water is then filtered out. Crystals are dried. That's it. All right, in the next lecture we'll see how metal hydroxides or alkalis, they are reacted with water. How alkalis are reacted with acids to form salt and water, and we call this method titration as well. So I'll see you in the next video.